In order to address external disturbances, regional resilience fosters adaptation capacity at local scale as well as systems control. However, adaptation capacity and systems control can be conflicting objectives that should be balanced. In this communication, we will show how, by regulating the decentralization level of a region's governance framework, it is possible to balance adaptation capacity and system control for an improved, resilient regional planning. This communication is structured in 5 sections. First, we will introduce the concepts of regional resilience and resilient planning, and we will explain the connection between decentralization, adaptation capacity, and systems control. Then, in the methodology, we present the way in which we address the search for a resilient plan of maintenance actions for the Spanish road network and the balance between adaptation capacity and systems control. In section 3, we analyze the results of the methodology, and in section 4 we draw the main conclusions. Finally, in section 5, we provide some references for those of you interested in reading more about urban vulnerability and resilient planning. Regional resilience, in broad, can be defined as the capacity of a territory to respond to and recover or profit from external perturbances. Regional resilience fosters adaptation capacity to respond to changing conditions and seeks as well to reduce structural imbalances and vulnerabilities. Therefore, regional resilience requires of some controlling force that makes it possible to carry out integrated plans aiming to correct these imbalances. Resilient planning, on the other hand, should provide answers to the questions of what actions are required and how these actions can be carried out. In consequence, resilient regional planning must provide a plan of actions for addressing external perturbance which, at the same time, help reducing structural imbalances. Besides, regional planning must promote adaptation capacity and preserve systems control, 2 objectives that usually are in conflict, but which can be balanced by regulating the decentralization level of governance structures. While the design of resilient actions has been extensively treated in the planning literature, there are but few studies tackling the balance between adaptation capacity and systems control. This communication focuses in the resilient planning of the maintenance of the Spanish road network. Spain is a country with a strongly decentralized governance framework composed of 50 provinces grouped in 17 regions. Previous work has evaluated the risk of each Spanish province of increasing urban vulnerability, which, together with the condition of the road network at each province, affords a comprehensive planning approach in which both biophysical and socioeconomic aspects are taken into account. Based on the information gathered from the EIEL, a comprehensive infrastructure inventory carried out by the Spanish government, the planning process looks for the quantity of each possible type of maintenance actions that should be performed along the next 10 years. The inventory classifies the road network's current condition in good, fair, and poor condition. Consequently, the types of action that can be taken are preservation, maintenance, or rehabilitation, depending on the condition of the road being treated. In the process of calculating the effect of actions over inventory, roads being treated will present a good condition at the end of the planning period, while those not being treated will degrade. For example, roads in good condition without preservation will be in fair condition at the end of the planning period, and so on. By means of this logic, we can estimate the condition of the road network at the end of the planning period. Based on this, we can easily compute both the condition score improvement as well as the urban vulnerability mitigation. The planning process is formulated as a multi-objective optimization process in which the decision variables are the quantity of each possible action to be carried out over each province. There are two types of objectives. Global objectives represent the performance of provinces at network level. These objectives are the minimization of economic cost, the maximization of urban vulnerability mitigation, and the maximization of the condition score improvement. There is also a local objectives, the roads condition improvement in the most vulnerable provinces, which aims to reduce structural imbalances between Spanish provinces. The multi-objective optimization process yields a set of Pareto optimal solutions from where, based on the decision maker's preferences, it is possible to select the proper plan of maintenance actions. As a second step, we need to design how to implement the selected plan of actions across our territory governance framework. We have formulated this governance framework as a hierarchical probabilistic relational model in which nodes are the entities and the links are the relational contracts. These relational contracts regulate the transference of decision capacity and responsibility from the top entity to the down entities. In this scheme, the rights represent the capacity of each down entity to adapt the baseline plan passed from the top entity, while the datis is the performance the down entity must achieve in exchange of the transferred decision capacity. We have formalized the logic underlying relational contracts. Rights are the range in which the down entity can modify the baseline plan of actions passed by the top entity, and they are used to build candidate-adapted plans. This is where duties come in. Duties are a range from the baseline performance that a candidate plan should meet to be acceptable. Accepted candidate plans are then carried out, determining the performance of top entities which, in turn, have their own top duties. That is, top entities' performance depends on down entities' adapted plans. In the case of top entities' performance falls without the top duty range, we will be before a failure or windfall event. And this framework, implemented as a Monte Carlo simulation uncertainty analysis method, affords the calculation of both the risk of worsening the performance and the opportunity of improving it. Finally, as in the case of the planning of actions, we resorted to multi-objective optimization to find out the optimal decentralization configurations. In the case of the implementation planning, the decision variables were the rights and the duties of each region and provinces, while the objectives were the maximization of local rights, the maximization of local duties, the maximization of local opportunity, and the minimization of global risk. Then, as in the case of the planning of actions, the decision maker can select the most suitable decentralization configuration. As to the results of the methodology, the first part of the planning process yielded a set of optimal solutions, which was filtered accordingly to the decision maker's preferences until a subset of relevant solutions was obtained. These relevant solutions revealed the trade-offs between objectives, providing some insights. For example, condition score improvement and urban vulnerability mitigation are aligned, are in conflict with economic cost. Besides, global and the most vulnerable entities' interests are aligned in condition score improvement. On the other hand, we also performed an uncertainty analysis over the relevant solutions. This analysis showed the inverse relationship between risk reduction and optimization, which means that as we approach the ideal solution, we increase the risk of not achieving the expected performance. This information was used to select planning alternative number 9 as the best for the planning of maintenance actions. And this was due because this alternative, despite it is a suboptimal solution in the urban vulnerability mitigation objective, it is quite robust regarding uncertainties in the condition score and urban vulnerability mitigation planning objectives. This plan of actions contains the guidelines for a maintenance project. In the case of the region of Valencia, for example, these guidelines consists in the quantity of each possible type of action that should be carried out in the next 10 years in each province. As to the implementation planning, the set of Pareto optimal solution confirms that adaptation capacity and local opportunity are in conflict with global risk reduction, and that local opportunity is in turn in conflict with data flexibility. As a final step for the selection of the implementation plan, we prioritized the socioeconomic criteria and therefore we selected the alternative with the lowest risk of deviation in urban vulnerability mitigation. In the case of the region of Valencia, the selected implementation plan consisted in a relational contract between the central government and the regional government with a rights range of 14 and duty flexibility of 3. In the case of Valencian provinces, they were entitled rights of 5% and duty flexibility of 5%. Based on these rights and duties, the lower and upper bounds for the generation of adapted plans are calculated, as well as the performance threshold that the adapted plan must achieve to be acceptable. As concluding remarks, regarding the question of what should be done, the selected plan of actions presented the most suitable trade-off between risk and optimization, thus providing a resilient solution for planning the maintenance of the Spanish road network. And regarding the question of how it could be done, the set of implementation alternatives clearly showed that the reduction of global risk objectives is in conflict with those of adaptation capacity and local opportunity. On the other hand, implementation alternative number 66 provides a robust decentralization configuration. This configuration, besides, minimizes the risk of deviation in urban vulnerability mitigation performance, which is the preferred criteria for the decision maker. Finally, here we provide some references for those of you interested in reading more about urban vulnerability and resilient planning. Thank you very much for your attention.